Hi there, welcome back to this channel. In this video, we're going to be talking about homolytic and heterolytic fission. You see, homolysis and hemolysis and heterolysis rather are two terms that we must understand in order to understand the mechanisms of reaction in organic chemistry. All right. So, what is homolysis and what is heterolysis? You see, the word homo means same. Homo means same, and lysis means cleavage or splitting apart, or separating. Is that okay? Now, homolysis is a type of cleavage that occurs between non-metals, two non-metals that are engaging in covalent bond, as we already know, in which that covalent bond splits apart and there's equal sharing of both electrons amidst the two species that are engaged in that bond. A classical example is this. The molecule, the chlorine molecule, which is basically two chlorine atoms coming together. Now, when this bond undergoes homolytic fission, what happens is recall that this bond represents two electrons. Is that okay? And what this means is that these two guys have two electrons that are joining them together. Is that okay? So when this bond breaks apart, what you are going to see is that one of the electrons is going to go to this chlorine and the second electron will go to this chlorine so that there is equal sharing of the electrons. Now notice what I drew here. What I drew is an half arrowhead. Now it is drawn from the center of the bond to this place and from the center of the bond to this other side to show that one of the electrons which is here came to this guy and one of the electrons which is here came to this guy. A full arrowhead means that there is an unequal. A full arrowhead means that the two electrons are going to the same atom, to one atom. Is that okay? So that's why we are drawing a half arrowhead to show that one electron is going to this guy and one electron is going to this guy. And that's why it's what called homolytic fission, because they bear the same number of electrons. So that at the end of the day, we have this 1, 2, 3, 4, 5, 6. This is a level structure, and the electrons that this one has acquired, and this other guy is going to also have the same electron, and of course the other electrons around it. Is that okay? I mean, following the Lewis structure. Is that okay? Now, what does this mean? Now, this is chlorine, Cl minus, that is very reactive. Why? Because it has a lone pair. A lone electron. This is not even a lone pair. Now, lone electrons are very reactive. They have very high reactivity. They have high reactivity because they are very unstable. High reactivity. Hence, they are called what? Free radicals. Free radicals. So, homolytic fission is what? Is common with what? Free radical reactions. And you see, it is not a very common reaction in organic chemistry simply because there is an exact amount of energy that must be put into the system for this kind of cleavage to occur. And that amount of energy is usually gotten from ultraviolet radiation, UV radiation from the sun. So if the necessary amount of energy is put into this, then homolytic fission occurs. Now, what is now heterolytic? Hetero means unequal, uneven, unequal, or uneven, so that there is dissimilar share of electron. So that if a particular atom A is bonding with a particular atom B, when a cleavage will occur, you know that this covalent bond, means that both of them share this electron. When cleavage occurs, both of these electrons will be transferred to this one guy, to only this guy. Both electrons will go to only one guy, or only this guy, based on what? The property called electronegativity. Now, I've explained this in the video that we made on bond polarization, what electronegativity is. So because this guy has a stronger pull for electron, for example, if species B has a stronger pull for electron over this guy, is going to pull the electron to itself. And because of that, it's going to gain what? A negative charge. Why this guy is going to get what? A formal positive charge. Now, they are going to gain formal charges here. Is that okay? Now, so consider, for example, the bond between the cleavage of CH3Cl, methyl chloride. We're going to have this. Now, chlorine wants to break apart. Now, if chlorine is to break apart. Because of a high electronegativity value, we say the electronegativity value of chlorine, electronegativity value of chlorine is approximately 3.0, while that of this is 2.5. That is, and we said that once it is greater than or equal to 0.5, that the bond is going to be polar, isn't it? So because this guy has a stronger pull for electron, when there is cleavage here, when this bond breaks, these two electrons will be transferred totally to this guy. Now notice, different from what I did here, we use a half arrowhead to denote the movement of electron here. Here we use a full arrowhead to show that both electrons are going to move onto this guy. Is that okay? And because of that, this guy is going to be electron deficient, hence it gains a what? A formal positive charge. Remember, electron deficient meaning that what? It has a what? A formal positive charge. Formal positive charge is showing that it is what? An electrophile. Electrophile means is what? It is now loving electrons. It's looking for electrons, hence it's love electrons. It is electron deficient. Then this guy gains a what? A formal negative charge. Why? Because it has acquired too much electron than it needs. Is that okay? Now, let's consider one more example. Even in an ordinary methane, for example. Now, if this bond were to break, for example, to form, now this will be called, in organic chemistry, these are called ions. This will be called our anion, the negative ion, and this will be called our cation. But because it is of an organic compound, it is called a carbocation. It is called what? A carbocation. A carbocation, why? Because it has lost electron and it has gained carbocation. Carbocation. Because it has gained what? A positive charge. So cations are positive charges, hence is what? A carbocation. This is methyl carbocation. Now, if it was just methane, for example, that underwent a heterolytic fission. Now, between this guy and this guy, which one has the highest negative value? The heterolytic value of carbon, we said, was 2.5, while of this was what? 2.1. So if the right amount of energy was supplied to break this bond, such as UV light, for example, for this guy to break also. Now, if this guy, the right amount of energy was supplied here, this bond will break and the total electron, because this guy has a stronger pull for the electron, so all electrons will move on this guy. And if all the electrons move on this guy, what do we have? We have what? We are going to have, this guy has acquired more electrons, so he's going to have what? A formal negative charge. While this guy, we have what? A formal positive charge because it has lost all its electrons. And this guy, for example, a solvent in a base, it could be abstracted by a base, a basic solution. It could be absorbed by the base. That is this guy as a proton, as you know, is going to be abstracted by that base in the solution. While this guy is going to be called a carbanion, carbonium or carbanion. You know, we said this one being a positive charge is called carbocation. Why this guy will call what? A carbonium ion or carbanion. Meaning that it is what? An organic compound with what? A negative charge. This is a methyl carbanion. And this is the basis of what? SN1, SN2 reaction, you know, where living groups where bond break heterolytically. So if bond break heterolytically, it gives rise to what? An anion and what? A cation. Is that okay? All right, so this is basically what electrolytic and homolytic fission is. And this is the end of the video. If you did gain value, make sure you subscribe to the channel and share the content with some of your friends who might need it. In the next video, we're going to be talking about the inductive, the SN1 and SN2 reaction. See you in the next video.